Now let us come to some basic properties of electric charge. There are some basic properties of electric charge which are associated with these. First is the additivity of charges. Additivity of charges, on that day we discussed what is additivity. Let us say we take 1 kilogram of any substance, 1 kilogram of, let us say, flour. If we add 2 more kilogram flour, so this total becomes 3 kilogram. This is become 3 kilogram. But for some quantities the additivity is not there, like we discussed pressure. Suppose we take 1 Pascal pressure and add 2 more Pascal pressure, so it won't become 3 Pascal pressure. Pressure will be adjusted according to the volume and force applied. Okay, so there is not additivity in pressure. So there may be many quantities in which additivity does not hold, but for charges it holds. So let us, but similar to mass, mass can only be added. Let us say you have 1 kilogram of an object, you have 3 kilogram and you have 4 kilogram. So you add 1 plus 3 plus 4, that is 8 kilogram of that object. But charges can come in two types, positive charges and negative charges. So if you have charges plus 3, plus 2 and minus 5, so net charge would be 0, because 3 plus 2, 5, minus 5 is 0, net charge is 0. Let us say we had another charge plus 3, so the total charge would be 3 plus 3 coulomb. Charges are added in terms of, sorry, this is not Q, this is coulomb. The unit of charge is coulomb. This is 3 coulomb, 2 coulomb, 5 coulomb, again 3 coulomb. So there is an additivity, and negative charges cancel the positive charge. So this is an important thing. So this is an important property of the additivity of charges. So we will discuss one question about this additivity of charges. So here you can see that if there are n charges, so the charges simply add Q1, Q2, Q3 up to Qn. In this example there are charges plus 1, plus 2, minus 3, plus 4, minus 5. So the overall charge is 1 plus 2, 3, minus 3, 0, plus 4, plus 4, minus 5, minus 1. So overall charge is conserved, and there is additivity of charges. Okay, now second property is there, charge is conserved. So similar to energy, charge is also conserved, mass is also conserved. We had discussed that mass can be converted only in energy, and in chemical reaction one type of mass is converted into another type of mass. Like if you fuse hydrogen and oxygen, so the water will come out. If you fuse hydrogen and oxygen, so the where is mass of oxygen is gone, mass of hydrogen is gone, they converted into mass of water. Similarly, we have seen that energy can be converted from one form to another form. Same holds true for charge. Charge is also conserved. Suppose there are two objects, object 1 and object 2. If you rub object A with object B, suppose object A is positively charged, then object B must be negatively charged. It cannot happen that A is positively charged and there is no charge on B. Charge must be conserved, and if A is charged with 1 coulomb, then B must be charged with minus 1 coulomb. Both should cancel each other because of the conservation of charges, plus 1 and minus 1, hence 0. Charge always remain conserved. Now we will use this property of charge conservation in one example which came last year. Suppose we have an iron ball 1, iron ball 2. There is some charge plus Q on this iron ball 1. There is some charge minus 3Q on this iron ball 2. Let us say we touch both these iron balls. So charge must be conserved, and there is an additivity of charges. So when we touch these, so plus q and minus 3q. So the total charge remains minus 2q, and since both the iron balls are similar, so at finally this cancel out, minus q charge will be here and minus q charge will be here. So both the spheres will become negatively, hence repel each other. So the question was that suppose we have two metal spheres, one has positive q charge, another one has minus 3q charge, what will be the nature when we touch them? So the nature will be repulsion, because now both of them are negatively charged, so nature is repulsion. Okay, similarly if we do, this was negatively charged minus q, this was plus 3q, then again we have touched each other. So what would happen? So this minus q is cancelled by plus 1q and still 2q remaining, which is distributed. This becomes plus q and this becomes plus q. So again there is a repulsion. If both are positive, again this is plus q, this is plus 3q, this 1q jumps from here to here, again this becomes 2q, this becomes 2q, again repulsion. Both are negative, this is negative, 1 minus jumps from here to here, again minus 2q, minus 2q. In all the cases you have seen that there would be a repulsion, there cannot be any attraction in all cases. Only one condition, when one sphere is positively charged, another with negatively charged with same, so there is neither repulsion nor attraction, because the charge will become zero, in this case. Okay, so now you have seen that there could be only repulsion, no attraction. Okay, so we have understood two properties, and please mark these questions because these are very important. Third property of charge is quantization of charge. On that day I have discussed an example. Suppose you go to market and you ask for chocolates. So you ask for 1 chocolate, 2 chocolate or 3 chocolate. You never say 2.73 chocolate. You never ask for 2.73. Similarly, there is a basic unit of charge E, which is called electronic charge E, and charge always come in multiple of that, 1E, 2E, 3E. So Q is total charge which is transferred, and it comes in multiple of E. So N is an integer, so this could be 1, 2, 3, 4 and so on. So charges will come like this, 1E, 2E, 3E, 4E, 5E. So there could be one question in your exam. Suppose, so you know that the value of this E, electric charge, is this given here, 1.602 into 10 to power minus 19 coulomb. But for your sake you can take only 1.6, not this figure, 1.6 into 10 to power minus 19. So charge would come in multiple of 1.6 into 10 to power minus 19. Suppose there is a question where there is a charge given which is not, a student does an experiment and he concludes that this much charge has been transferred, let us say 2.7 into 10 to power minus 19 coulomb. So was the student correct or not? So student was definitely wrong, because that charge what he has calculated or she has calculated is not a multiple of E, simple multiple of E. So that comes around 2.7 upon 1.6, that does not come a whole number. Either 1.6 or 3.2 or multiple of that comes as a whole number. So his or her experiment is completely wrong. He or she must repeat the experiment. This is an important property, or 1 mark question can come onto this as well.